Here, on the International Space Station, the next meal is only a supply ship away. But how do we feed a crew of 6 astronauts on a 3-year mission to Mars? ESA and the other international space agencies are planning manned missions to the Moon and Mars in the future. For that length of time, a crew of 6 would need many tons of food and drinking water, let alone all the other vital supplies that they would require. Scientists are researching how to extend the shelf life of food for up to 5 years, whilst maintaining a variety of great-tasting foods. However, the most powerful rocket in the world today can only carry a payload of a few tons into space. And a trip to Mars would need many tons of food and supplies. The only practical way to supply long-term missions is to launch the equivalent of a farm into space and grow at least some food, whilst recycling water and waste to supply the crew for long periods of time. When we start to build bases on the Moon and Mars, we also have to grow food and recycle waste to enable us to stay on these distant planets for years at a time. ESA has a number of research projects for growing and recycling food into space. ESA scientist Christel Payet works on one of these, the Melissa project.
The Melissa project addresses actually the supply of air, water and food for the crew in a closed regenerative system, in the sense that we take actually the waste which are produced by the crew, being fecal material, urine, that we degrade, and from that we regenerate the water, the air, and we produce as well food.
Today, the target for a Mars mission is to be able to recycle roughly 40% of the food. Why 40% of the food? Because if you recycle or produce 40% of the food of the crew, directly you produce 100% of oxygen and 100% of the water that the crew will need.
The question of which foodstuffs to actually grow in the precious reclaimed resources is not simply a scientific one.
There is another criteria which is very important, is the quality of the food you will need to produce. You can fill the requirement in terms of nutrition with wheat only, but you have to consider the acceptance. And if we feed the crew with only wheat, of course we will have probably some difficulties.
You just want to eat a fresh tomato or fresh cucumber or a fresh fruit.
Melissa has already successfully trialed a closed water recycling system, but this technology is not just applicable in space.
You know that today everybody is challenged by the environmental issue and the global warming issues specifically. The water quality, the air quality, the contaminants and everything. And we know already, because we have some success, that the Melissa technology is applicable to Earth, which are already used in the terrestrial application. And I think it's important that people realize this.
Since the beginnings of the exploration of space, there have been many technological spin-offs, from advanced composite materials to GPS that we all use in our phones and sat-navs every day. And in a world of increasing population and decreasing resources, systems such as Melissa, developed for space travel, could be the most invaluable spin-off yet. We've seen in this program that food is literally the fuel of life, on Earth and in space. Ensuring adequate supplies of food always has and always will be the most important activity that all living things, from plankton to planetary explorers, do. As we've seen, the logistics of long-term spaceflight require huge technological innovations to supply crews with the food they need, both for their physiological and psychological well-being as they travel to distant planets. The Earth is a self-sustaining ecosystem. A manned spacecraft that will be away from its home planet for years will also have to be a self-sustaining ecosystem. Or to put it another way, a miniature planet Earth. In many ways, the technological challenges for ensuring future food supplies on Earth are the same as in space.